Okie dokie, y'all. All right, bell ringer. So this is the 8th bell ringer that you should have. Okay, we've got 2 more, I believe. Let me double check. So yeah, we've got 2 more. So we'll do one on tomorrow, Thursday. You won't have one on Friday. You'll come back and you'll have your final bell ringer on Monday, which means your bell ringer quiz will be on Tuesday. Okay. So that bell ringer quiz is just a scavenger hunt. You're just going to be looking through your bell ringers and you're going to be looking for the correct answers. Okay. So that is going to be done in our class period. You will do that. You will submit that. There is a time limit, so you need to make sure that you have all of your stuff copied down. If you haven't, you need to get with someone at your table and take pictures of them. And then before that quiz, make sure you get all of that copied down. So the way it's going to work is you'll be doing it on Canvas, but you'll be flipping through your notebook, finding the answers. So as long as you have everything written down, you should be good to go for this bell ringer quiz. That's for virtual students and for people that have been quarantined, people that are in class. It's for everybody. So if you don't have 8 at this moment, no matter who you are, you need to get with somebody and make sure you get all 8 of those. All right, so let's check this one. This is about the perimeter, circumference, and area. So it says find the perimeter or circumference and area of each of the following figures. So how do we find the perimeter of a rectangle? Add all the sides. Okay. There is a fancy formula that you can use: 2 length plus 2 width. That's fine too. Any of those ways are going to be fine for finding the perimeter. It's not going to matter. If you do 2 times 24, that's the same thing as adding 24 plus 24. And then if you do 2 times 14, again, that's the same thing as 14 plus 14. So what's 2 times 24? 48. What's 2 times 14? Is that 28? Yeah. Okay. So then you add them up, and that's going to give you 76. Is that right? So the perimeter is 76. Now, how do you find the area of a rectangle? Length times width. So you multiply length times width, which is going to be 24 times 14, or vice versa, 14 times 24, however you see it. What is 24 times 14? Say that again. 336. And we probably should be saying meters squared because area is squared, and this one is just meters. That one's not squared. Okay, so the perimeter is just a measurement, so it's just in meters. Area would be meters squared. Okay, now we are looking at number 2, which is a triangle. How do you find the perimeter of a triangle? Add all sides. That says all. Add all sides. Okay, so if I'm going to add all the sides, this dash right here is not a part of that. We're just wanting this side, which is 13, plus this side, which is 18, plus the long side, which is 25.9. What is that all added together? What? 56.9? And that's inches. Just flat, nothing squared. It's just a measurement. Now, how do you find the area of a triangle? 1/2 base times height. Okay, so we're going to have 1/2. The base is what? 18. What's the height? That's why they have that weird dash thing off to the side so that you can see the actual height. Okay, so the height is 12. So half of 18 would be 9. 9 times 12 is not 108. Did I make that up? It is 108 inches. You wouldn't have to what? No. Yeah, because you're just multiplying 1/2 times what's beside it times what's beside it. It's not like distributive property. If it was distributive, then this would have to be like plus here. But since everyone's being multiplied, don't distribute that out. That's a good question, though. So just know only do that distributive if they're in the same set of parentheses. All right, now what about a circle? How do you find the circumference of a circle? I don't know if I have this one memorized. Circumference is 2 pi r, or pi times diameter. Okay, so those are your formulas. So pi is what? 3.14-ish, because you know it goes on and on and on forever. Okay. You should have a calculator that has a pi button at this point in your education, because you can use those scientific calculators. If that's the case, just press the button. Don't use the 3.14, because that is going to round your answer too much. When you take the ACT, a lot of times they leave pi as an answer. Like when you would do something like this, it would say 2 pi. What's the radius? 18. So what's 2 times 18? A lot of times it will have an answer choice on ACT as 36 pi. So they're not even plugging in that 3.14. They're not rounding. They're just leaving that as their answer. That's the only way that it can be exact, okay? Because even if we press the button on our calculator or we use 3.14, we're ultimately going to be rounding, which means it's not an exact answer. So if you see that on the ACT, just realize they didn't type that into their calculator. Now, if you did type that into your calculator, what is it going to be approximately? Did y'all do that? What is it? 113.1, and this is feet. Now, the circumference is really just like the perimeter. It's just a measurement, okay? So if I had a string, I could go all the way around that circle, and then I would measure it out. Not squared, not anything fancy. It's just feet. Now, the area. How do you find the area of a circle? That one is pi r squared. I should really have these memorized as a geometry teacher, but there's that. So the radius is 18. We already discussed that. Pi times 18 squared. 18 squared is not 18 times 18. Okay, it's 18. It's not 18 times 2. Okay, it's not 18 times 2. It's 18 times 18. So if you don't have a calculator that lets you do that, then you would need to type in 18 times 18 to get that. Pi times 18 squared is 1017.88, or you could round that up to 9. Again, this is still a approximate answer, okay? Still an approximate answer, and this is feet squared because it is an area. Okay. All right. Make sure you have all of that written down, all of those notes. I am going to pass you out today's assignment, but I want you to get out the homework that you did for me that you already turned in with the proofs so that we can take a look at that. Shame on you. You liking being at school again? Good. Just for the fact that you get to see other people. You're welcome. Where we at? Where's it at? Can I see? Where's the where's the split at? At the top of that, does it show where we're at? Okay, I see it.
Yeah,
God, it's so close. This. I have no idea. I just know it's so close. I'm glad I'm not counting votes. That's a lot of pressure. You're welcome. Okay, you guys. So let's start with our homework from last class period. What the heck? There we are. Okay, because last class period we were working on the proofs, and there were a couple people email me about those, so I wanted to make sure that we discuss those. Of course, I only printed the first page. So here's the first two. So check your work, make sure you did that correctly. And let me print that second page real quick. How'd y'all do on that? Y'all got it? Y'all did okay? Where's that? The fourth one? AC. It's flipped backwards. It does matter because look, AC is the first two. So you're right. It should be CG. So it should be flipped around. But yeah, I guess it's not that big of a deal because it's not the whole thing, but I would say have it matched. Okay, here is these two. Everybody was freaking out because I think I said there was probably two sides and two side angle sides. Well, it wasn't. There was only one side and then three side angle sides. You put vertical angles over here. Well, that is okay in the fact that you are correct in your like information, except for that doesn't give you side angle side. So in order to get side angle side, you have to have the included angle. Well, if you use this vertical angle down here, then you have to use these two sides. That's not the two sides you know about. Okay, so that's why you can't use that angle. That's why you have to use the alternate interior angles, which is A and E. So there are vertical angles in that situation, but it doesn't help us prove with side angle side. With the little hashes, she put those on there as she did this. So she walked through it and said AB is congruent to DE. So she made that hash. Then we know that they're parallel and we know that C is the midpoint. Well, if C is the midpoint, that's what tells you that these two are going to be congruent. So knowing that about your sides, then you have to choose angle A and angle E because those are the included angles. Yes, sir. Sure. Yeah, that's fine. Then yours would have looked like over here, yours would have looked like S, A, but S is not one. So anytime you get that, don't write it like that. Put it in the order of the included angle. Yeah. SAS or what? This angle is this A and this E because you know the side here and you know the side there. So you have to use that included angle. So it's got to be that one that's included because you know the top side and you know this side. So you've got to use that one. That's what's giving you the side angle side. And like, just like what I was saying for earlier, like he was talking about the vertical angles. Well, if you did that, then you've got side, side, and then this angle down here, but we don't have side, side angle. Like that's not one. Anytime you have ASS, like that should like make you giggle inside, but it also should be like code, like this is not correct. Okay. There's no such thing as side, side angle or angle, side, side. It has to be the included angle or else it's not enough proof for us to prove that they're congruent triangles. Any other questions? This is challenging every year, okay? Every year students struggle with this, okay? So make sure you are asking questions. Make sure you are trying to learn this. Like this is when people like start getting to the point that geometry is difficult, okay? Because you are trying to figure out how you know each one is, and you have to use what you know and make it make sense. Like with this second one down here, they tell you that these two are congruent. So you already know that those two are congruent. You also know the reflexive property. So since you know this one and this one, since you know those two sides, you have to talk about the included angle, okay? It has to be that included angle. You can't talk about the angle down here or the angle up top because those are not the included angles, okay? We're going to keep practicing this one today. So that's what your lesson is about today. So get out the paper that I just gave you. You do have a quiz tomorrow. It is in class and you are not using your notes. It's going to be on the last 3 lessons, the one that we did on Thursday of last week, Monday of this week, and today's. It's on side, 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 side angle, side, and triangle congruency. So like that very first lesson was just about like figuring out who's congruent to who, like based off the name. That was easy, yeah. I think all quizzes are going to be 30 points unless it's just like a crazy big quiz. You're going to do fine. Okay, y'all. Let's look. Now, some of this I'm going to let you do on your own, but I want to at least get you started. So these already have the markings for you. So the only thing that you have to do is look at what they have marked and decide what it's going to be. So it tells you, state whether the triangles could be proven congruent. So some of them may not be. Then if you have decided, yes, the hash marks prove that it's congruent, then you decide whether it's by side, 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 or side, angle, side. Because again, we're still only using these 2. We'll add the other 2 in on Friday. Then it says, then write a congruency statement. Okay, so if we look at the first one, this hash mark is good to go. This is the same one. Then we have a double hash mark over here, a double over there. So right now we know 2 sides, and then you know this included angle right there because it's the angle in between the 2 sides, right? So this is side, included angle, side. So we're good. They're congruent. Then they want you to write a congruency statement. When you write a congruency statement, you have to match them up. It has to be in order. So I'm going to start with Q and I'm going to say triangle Q. I'm going to come up the line with 1 hash mark to Y, down the line with 2 hash marks T. Q, Y, T is congruent to triangle. I'm starting at the bottom of the 1 hash mark, which is C, up that to K, down the double hash to P. And that's how I'm writing my congruency statement. It has to match up, okay? So you can't just put 3 from here and 3 from here. You have to make it match up. Now, yours and your neighbors may not be exactly the same, and that would be okay, because I could have written this like YTQ, KPC, and that would have been okay. So there are multiple ways for you to do it, but all of the parts have to match up. Q and C have to go together. Y and K have to go together. T and P have to go together. Okay? Now, let's look at number 4. Okay, let's look at number 4. So if we look at this one, hash mark here, hash mark here. That's good. That's a side. Hash mark here, that's good. So we've got 2 sides. And then the angle is over here. So, do we have congruent triangles? No, because the angle is not included. Okay, this would be ASS, which we don't have that. That's not an option. Okay, or SSA. It has to be in the correct order. In order for this one to be congruent, we would have needed this angle, because we would have needed the included angle. So this one is not congruent. Got it? Try the other ones. It's on paper, but it's on Edulastic. Just like the last one, where it had 2 pieces of paper. Do you want me to like print you the paper copy is what you're saying? Yeah, I can do that. You still have to input your answers into Edulastic. You're fine. You're just... Lizzie, you're killing me right now. What do you mean? Do the first 8. They're congruent, so just write a congruency statement. So triangle blah, blah, blah equals triangle blah, blah, blah. Oh, it means they're parallel. So that's the one that's going to have those alternate interior angles. What? Well, this one is SSS because you know all your sides. This, no, that one's SSS too. because you know all of the sides. You've got the hash mark here for 1, 2, and then you know this one because of the reflexive property. So if you have all 3 of the hash marks, then you know it's side, side, side.
So if they're automatically reflected, they're going to be up and down?
Pretty much, yeah. Okay, I hate to rush y'all, but we need to get through the last part of this lesson too, because like I said, you have a quiz tomorrow. So let's look at number 2. So if we look at this one, we've got tick mark, hash mark there, hash mark there. Now, do we know about an angle or do we know about a side? The reflexive property tells us that AC is going to equal itself. So you have all 3 sides. So that means this is SSS, side, side, side. Then you write your congruency statement. Triangle ABC is congruent to. Now, be careful. I did A to B and then B to C. So I started with A, went through the double hash, B to C through the single hash. So for this one, I'm going to go C to D through the double hash, D to A through the single hash. So make sure when you're doing this that you do it correct. I forgot my triangle. All right, look at number 3. We know the outer side. They identify the angle. What else do we know about these? Don't they share MK? Both triangles share MK, so that's the reflexive property. So they both have that in common. Do we have the included angle? Yep. So this one's side, angle, side. Because you have that included angle there, so you're good to go. Then you name them out. Triangle, I'm going to start JMK. And like I said, you don't have to have yours exactly the same as me. That's fine if you don't. I did JMK. That's going to be LKM. So as long as you've got J and L matched up, M and K matched up, K and M matched up, then you're good to go. What about number 5? SSS, because this one is the reflexive property. If you've got all 3 hashed out, then you're good to go with that. So I'm going to call this one ECF. And I'm going to say it's congruent to, I did ECF, so EDF. Okay. And like a good way that Joseph said was to like look at it as if it's reflected, which is cool. So then you can kind of map it back onto itself and see your matching pieces. All right, what about 6? Do you see that this one gives you the markings to show that it's parallel? You see that? So knowing that it's parallel, remember, tells you about tells you about corresponding angles, alternate interior angles, and exterior angles. So when I'm looking at this, I can see the hash marks here. What I would need to be able to prove congruency is angle D up top, because that's the included angle. Is there any way that we can know that D is congruent to angle E? Alternate interior angles. They're going between the parallel lines. They're on opposite sides. So those are going to be parallel because of the alternate interior angles. So this is side, angle, side. So I'm going to call it triangle JDA and triangle MEA. Number 7, yes or no? No, this is not the included angle. There's no such thing as ASS, so this one's not congruent. Okay. For 8, yes or no? What type of angles are these? Those are vertical angles. So we have the sides on the opposite, surrounding that. So this is side angle side. And I'm going to call it triangle BCA and DCE. And like I said, yours doesn't have to match mine. You could have done ABC is equal to whatever. I didn't do it that way. I started with hash mark 1 through hash mark 2. I just like to follow the hash mark so that I can keep something in my mind to keep me on track. Okay, so that's how I did that. Now, the next several are practice with proofs. We're going to skip that for now and go to the back and look at using this with the coordinate plane. Okay, so if you have to prove that triangles are congruent based on the coordinate plane, what are you going to have to do? That's right, the distance formula. The distance formula is x2 minus x1 squared plus y2 minus y1 squared. If you don't know that, write that down. You have to have that memorized for tomorrow's quiz. I'm not giving that to you. You're not going to have that on your notes. You need to have that memorized. So we deal with PQ. We find the distance of PQ. This will be on your quiz tomorrow. So we're dealing with our x's. Again, it doesn't matter which order you do it. You just have to keep it organized. So I'm going from Q to P. -3 minus 5 squared. 7 minus -4, so plus 4 squared. Now, I will probably let you guys use these calculators tomorrow, either these fancy ones or the ones in the back. Okay, so I'll just sanitize them after y'all use them. But if you type this in your calculator, don't type in the radical. Remember how you have your radical here? Remember how we talked about not typing that in? Because you can leave it without that. So I'm just going to put -3 minus 5, close parentheses, squared, plus 7 plus 4, close parentheses, squared. That equals 185. So the square root of 185. Because remember, we can match up the square roots. We don't have to have the decimal. We can just match the square roots. So now I'm going to do x, y. So I'm going to start with y, which is 9 minus -2, so plus 2, and 7 minus -1, which is plus 1 squared. Now, if these don't match, do I know that for sure this is not a congruent triangle? Well, this is proving it using side, side, side. So if all the sides don't match, then it's not congruent. Okay, so far so good. This one's 185 as well. So we're matched up. We're trying to prove that their congruency is all going to be congruent. In order to prove this, we need all of the sides to match. Okay, so we've got that. Now we're going on to Q. Okay, QR. So I go from 0 minus Q, which is -3, so plus 3. And then 2 minus 7. I'm going to type that in. 34. Okay, now I'm going to do y to z. So this is not hard, you guys. It's just repetitive. It's remembering the formula. It just takes a second to do it. So I'm going to type this one in. $61. So is this going to be congruent? No. How do you know it's not congruent? Not all of the sides are the same. If the sides aren't the same, then it's not going to be congruent. Now, just to be sure, I'm going to go ahead and check PR and just make sure that PR is not 61, because that, I guess, is a possibility. And I don't want them to trick us, because that would be embarrassing. So R to P would be 0 minus 5 squared. And 2 minus negative 4 squared. So I just want to make sure that they're not switching it up on us, because I don't have the key in front of me. So they could be being sneaky. Is it? It sure is. So don't listen to Miss Cole. You need to check all of them. So now what does this one down here need to be? We need this one to be 34. I'm glad we checked that. X. Okay. Let's see if it's 34. Is it? Those of you that are going faster than me? Well, looky there. What do you know? So, it is congruent. So, yes, congruent. And then we have to write our congruency statement. So, triangle P to Q to R is congruent to, we have to write it in the correct order. So P to Q is the same as X to Y. So that's fine. Then the last two, QR, is congruent to who? XZ. So we'll have that Z there. XYZ. Is that going to match up? PQR XYZ. I forgot what? Oh, I forgot the triangle. Always. All right. Your homework for tonight is what you already have at home. Okay. You already have that sheet at home. You did the 7, 8, 9, and 10. You submitted 7, 8, 9, and 10. Well, your homework's the other ones that you have not submitted. Let me look at it. No, it's just this sheet. You've already done this part. Okay, so you've already done this part. So you need to do those 6 for sure, and then 11's only one problem. So yes, do 1 through 6, and then number 11. Oh yeah. Let me turn this off so everybody's not listening to our business.